In this video, we're going to be talking about velocity time graphs. Now, a velocity time graph is just another way of visualizing how an object is moving. We've got velocity on the vertical axis, and like when we had displacement time graphs, time is still on the horizontal axis for this. Now, velocity is kind of like a speed, but it's a vector version, so we need to consider which way an object is traveling. Now, let's look at this specific velocity time graph. We've got three objects, blue, green, and red, and we've got three lines, all horizontal lines on the velocity time graph. Now, a straight flat line on a velocity time graph indicates that the velocity is not changing. This means that the objects are going to move at a constant rate, a constant speed. Because of the different positions, the different heights on the graph, some of these objects are going to move faster than others. Now notice we've got this red line underneath the axis. What do you think that's going to mean? Pause the video if you need to think about it. I'm going to click and we're going to see it move right now. You can see that the red object is moving the opposite direction to the other two. You may have noticed the other two speeding off the screen. The blue one was the fastest because it had the highest velocity. Now, if you have a diagonal line on a velocity time graph, it indicates that the velocity is changing. In this case, we've got an object that starts at rest, the velocity is 0, and as time goes on, it gets faster and faster. You can see that moving right now. You can see the object picking up speed and accelerating off the screen. Now, the gradient of a velocity time graph, if we look at the two parts, we've got velocity on the vertical, the y, and we've got time on the horizontal, the x. If we divide one by the other, we get change of velocity over change in time, which is the formula for acceleration. So calculating the gradient on a velocity time graph gives us the acceleration of an object. Now let's look at one more specific situation here. This object has got a positive initial velocity, it starts up here, but it has a negative acceleration, so the velocity is decreasing as time goes on. Now let's split this journey up into three sections. Have a think about what's going to happen at each stage here. Maybe pause the video again, and when you unpause it, we'll have a little look at the motion. The object is still moving forwards, it stops instantaneously, and then it moves backwards slightly. Notice in this first section of the journey, the object was slowing down, but still moving forwards. When it crossed through the axes, for an instant it stopped, and then as it went a little bit further on underneath the axis, it started moving backwards. Now, something else that's useful with velocity time graphs is we can calculate a displacement from them. So let's take an example here where an object is traveling 5 meters per second for 8 seconds. Now, it's quite easy to do in this case because it's a constant velocity. We can just rearrange the velocity formula. We can multiply the velocity and time together to get the displacement. In this case, it's just going to be 5 times 8, which is 40. Now, this is also the area of the rectangle underneath this line. It's a rectangle with base 8 and height 5. And we get our 40 meters that way. So it turns out that if we have a more complex graph, we can still find the displacement by considering the area underneath it, but we might have to split our compound shape into things that we can manage, like trapeziums, triangles, or rectangles. In this instance, we can split it up into one of each. Again, if you want to pause the video and have a try yourself, see what you get out for the displacement, and unpause it whenever you're ready. In this case, we've got a rectangle which has an area of 12. It represents 12 meters traveled. Our triangle gives us 4. And our trapezium gives us 7.5. And those can be added together to give a total displacement of 23.5 meters traveled. If you don't like the trapezium formula, what you can do is you can split it up into a little rectangle and a triangle as well, and that will work too. Exactly the same area.